everybody, this video today is looking at a vertical mill machine. The one we're looking at is the first vertical mill machine. Please refer to your booklets for information on the type of cutting tools for both the lathe and mill machine. So you got your lathe tools, they're your carbide cutters, turning down tools. On the milling machine, we're looking at the different types of cutting tools we have. Generally the end mill, the slot drill, and you got these collets for holding those tools. So let's look at those tools. That's an end mill, which you see in the picture there. That's got 4 cutting teeth on it. And this is the RE collet. So these come in different size diameters to fit different diameters of the tools. So this is an example of a slot drill that you're using in your project, a 60mm slot drill. And again, they fit into those collets, those RE collets for holding it. It's been gripped like so into the machine. And then as I said, they come in different diameters, different sizes, according to the tools you're putting into the collets. So, the basic thing of the milling machine. This is a vertical milling machine, as we can see here on the controls that we're at the 0 position point. The head can vertically move and tilt in various degrees of angle. And the gear setting at the moment, it's in its high setting. You can alter this and change it to high and low gear speed settings. So the speed control is read from above, and you set the speed when the machine is running on. Just on that point, let's look at the RPM on our booklets. We can clearly see parts of that milling machine. Maybe look at that first. We're looking at there is that we see on the vertical milling machine all different components. We have the column, the head, the brake handle, the cutter itself, the table, the vise, the saddle, the knee of the machine, the knee dial of the machine main control, the controller itself. This is your y-axis. This is the lock for the y-axis to stop you from moving the y-axis if you want to keep it stationary. This is the x-axis locks, and this is movement in the x-axis, traveling up and down the way. The z-axis is controlled by the knee of the machine. Just be careful that handle moves out at all times. And you can raise and lower the bed of the machine up and down. And one full turn of the knee dial is 2.5mm. One full turn in the x-axis motion is 5mm. So we can see then, generally refer to your toolbook for calculating out the RPM for the machine. Referring to your student handbook, D for milling and turning the same form of a slight variation in the D value. The S value depends on the cutting speed, for the material and the tool you're cutting with. The D in this instance is going to be represented by the cutter diameter. So that will be the diameter of your cutting tool. So if we take an approximate valuation there, going for a cutting speed of a 1200 RPM, and I want to put a cutting tool in, and I want to cut aluminium. So how do we put material in the machine? For the first time, let's look at that. So the material, it's a piece of aluminium block that you want to get to face off. Usually set that on a set of parallels. You don't just place the material into the vise like so, because then how can you verify and ensure that it's perpendicular to the cutter? And to do that, you get a set of parallels, and they come in various different thicknesses and heights. So depending on the size of material you want to do, you pop them inside, and you set your material up on top of that. Then you tighten up on your vise, and then you ensure then that it's nice and secure. It's nice and secure by tapping down on the material, and then tapping down on the handle to make sure it's firmly held in position and it's secured under the devices. So, to put your tool in for the first time, you're going to move to one side, and it's done by automatically done by compressed air. So I want to install today an end mill to face off the top surface of the material. So I pop that cutter inside into its holder, and then I slide them into the machine. These are equal size ones, RE collets. That groove fits along a little groove inside the machine itself. As you push up, you have to ensure that the quill lock here is fully up. That's for drilling. That's fully up and locked, and the white button brings you up. So unless you're fully up and locked, then it's not going to securely get in place. So when you're fully up and locked, you hear the difference in the noise, versus if it's down, if the quill is down and you try to bring the tool in, you hear a difference of a. So you need to ensure that the quill is fully up and locked to take the tool up or to remove the tool. So that's removing it with the black button. And to put it back in again, you're just sliding up in position, lining up that little groove, pushing up, and then right. The tool is installed. And then to set up, you can control the X of the machine by pressing the X button, the DRO, and you can control the distance you travel in the tool in the X direction. And the same way with the Y. By pressing the Y button, you can control the distance you travel where the tool is moving on the Y axis. So I want to bring the tool over to touch the top of the bottom of the tool off the top of the part so it's 0 to Z axis. So to do that now, bring the tool over to the material of the part, into position. I'm going to close up the guard to ensure it's set up. So as you can see, we want the guard in position the very first time, and now what I'm trying to do is get it just in position. So I'm going to lower down the quill and lock that approximately 5 mm off the top of the part. Pause. So now with the door locked, we can get power to the machine, and with power to the machine, we can turn on the coolant pump. Before I turn on the coolant pump, I want to ensure that the valve nozzle is pointed down into the drip tray and not pointing out towards it. The valve itself controls the flow of the valve, and you're turning on the pump. Now you can get the coolant coming out. So we're going to stick a piece of paper to the top of the block, and that will allow us to accurately gauge the thickness of the height of the tool away from the part. So the paper is stuck to the block of the part, and we're going to catch the tool, make the tool catch that paper. So to turn on the machine for the first time, we make sure it's in clockwise position motion. That turns on the cutter, and now we're going to raise up the bed of the machine to the tool. This is the knee of the machine, so you raise it up to the point where it catches the paper. It's caught the paper there now, so literally at that point we're going to 0 the Z axis. So we're literally approximately about 1 or 2 microns off the top surface. So we've 0'd that, so 1 full turn, as we can clearly see there, of the knee dial is 2.5 mm, so 1 full revolution. And each increment is 0.02 of a micron, similar to vernier calipers. So to move to one side manually, it's in the X direction and in the Y axis. Now if you wanted to take off 0.5 mm off the top surface, what you do there is, while we have that 0'd, some of the mill machines in the workshop will have this DRO with the Z zeroing feature here, allowing us to store it. But not all mill machines will have it. This one actually has the feature, so this is now reading 0 and syncing with that one there on the knee. So we're just up the machine by 1 mm on the knee dial, which corresponds above on the DRO. So we're reading one on the knee dial and 1 on the DRO display. Then we can manually machine down along the part. But before, we want to adjust our speed to our machine to match our cutter. So while the machine is on, you adjust up your RPM, suit the diameter of the cutter that you're using. If it's a diameter 20, or if it's diameter 16 or 10, you adjust accordingly to your formula. So you're engaging in on the handle and rotating, traveling down along machining. And that's what's called facing off the part. So I want to go now with automatic feed. We twist on this dial here, sends power to the controller, and then we can control the automatic feed feature and the speed of the feed. So we can adjust in our Y axis and machine across the part. changing the direction of the lever, you're changing it's going over and back across the material. So to stop the machine, it's pressed by the red button here, and then you have a brake above the cutter still rotating. If you power the machine on and you've been to an accident and you want the emergency stop switch, that will kill power to the machine. But to start the machine again, you need to twist the isolator switch and open to power on the machine and power on the cutter. That's how you safely stop and start the machine. And then you move to one side if you want to change the cutter out and put in a chuck or so forth to do drilling operations. Make sure you're clear of the chuck so you cannot get set to do it safely. So retract back up the quill, close the lock, and the black button can to pop the chuck in. There's separate chucks. Morris taper chuck is for a lathe, or for the milling machine you can see it's a straight shank or a collet for the milling machine. So to put a chuck in, same way, you rotate around, it gets into position, and then you push up the way. So as you push up, the white button brings you up, and then the black button brings you down. And that controls a short video on how to use the milling machine. Please refer to the other videos for on the project.